It's another math day here with teacher Jenny. Join me for another topic. This time, we're talking about solving exponential equations with this kind of pattern or problem. Now, as soon as you can see that your exponential equation here contains on the left side or right side might be with two bases, we are going to solve it like this. So let's start with this one. So we have here the first given as 2 to the power of x plus 2. And then we have another base, which is 2 to the power of 3x minus 1. So if you cannot see anything that is connecting your two bases there, automatic, your operation in between is multiplication. So please know that one. This is equal to 8. And then, of course, we are going to solve the exponential equation, meaning to say we wish to have all the bases there on your left side and the right side to be the same. So on the left side, we have similar bases, so no problem with it. So on the right side, we have to express our 8 in the base of 2. So let's copy the first one here. 2 to the power of x plus 2 times 2 to the power of 3x minus 1. So this is equal to, your 8 there can be expressed into 2 times 4, and then your 4 here can be expressed into 2 times 2. So our base here is 2. We have all the factors of 8 will be with 2. So we have 1, 2, 3. And that number of 2's appearing as the factors of 8 will be your exponent. So we have 2 to the power of 3. Next one, we are going to simplify our left side because what we wanted to have is single base on the left side and single base on the right side. So what we are going to do is, since your left side has similar bases, so all you have to do is to apply product rule under the laws of exponent or the rules of exponent. So how does it work? When you say similar bases and you are multiplying, this is what we call as product rule, in which we are going to simply add our exponents. So we copy our common base here, which is 2. So we have 2 to the power of, we have our first exponent as x plus 2. That will be added to our second exponent, which is 3x minus 1. And then that will be equal to 2 to the power of 3. Now, next one, we try to simplify our left side. So we have here 2, and on the exponent, we can combine like terms. So we have x plus 3x, that will be 4x, and 2 plus negative 1 or 2 minus 1, that will be equal to positive 1. And this is now equal to 2 to the power of 3. Now, next one, since we have here our single bases on the left side and right side, and they are the same, so all we have to do is to get our exponents on the left side and right side and put that one into an equation. Because again, under the property of your exponential equation, that your bases, if the bases are the same, automatic, your exponents are also the same, and vice versa. So that would simply mean that since we have similar bases here, so that would simply mean that we have 4x plus 1. This is equal to our right side exponent, which is equal to 3. And then we're solving for x. So we move on to the other side. So this is now 4x equal to 3 minus 1. Now simplifying this one, we have 4x equal to 2. And then we're dividing this side by 4, and so with the side, because we're solving for x, so our x here will be equal to 1/2. So there you go with your answer. You can try to check your solution there by simply plugging in that back to your entire equation and checking if this left side really here is equal to 8. So once you see that that is equal to 8, then that would simply mean that your answer is correct. Okay? Let's move on to the next example. So again, we have here on the left side, we've got two bases. And the right side, we only have one base. So we are to express this one into a single base. Now, or we are to express this one into similar bases. But looking at 4 and 16, they are not. So we have to come up with a similar base on 4 and 16. Now, notice 4 and 16 can be expressed in terms of base 4, But if you try to check on the right side, it has base 2. So it's not gonna be base 4, but it's gonna be base 2 because again, your 4 can be expressed in base 2, your 16 can also be expressed in base 2. So let's express every base there in base 2. So we have for 4, we have 2 times 2. That means to say we have 2 to the power of 2 as your 4. And we still have our exponent, which is x minus 3. Next, we have 16. 16 here can be expressed into like this. If we try to get our 2 out as the base, we have 2 here and 8. And then from 8, we have 2 and 4. From 4, we can have 2 and 2. So we have 1, 2, 3, 4 2's in there. So that would simply mean our base 2 is with an exponent of 4 for that 16. And again, we have an exponent here, which is negative 2x plus 2. We copy that, and this is equal to 2 to the power of 3x minus 9. Now, all the bases there are similar, so what we are going to do is to simplify the left side. So again, we have here exponent inside, exponent outside. This is what we call as power to power rule under the laws of exponent or rules of exponent. So if you've got power to power there, that means to say we had to multiply inner exponent and outer exponent. So this is now 2 to the power of 2 times x, that will be 2x. 2 times negative 3, that will be negative 6. And then we go to the second base. This is now 2 to the power of 4 times negative 2x, because again, this is power to power rule. We have 4 times negative 2x, that will be negative 8x. 4 times positive 2, that will be positive 8 or plus 8. And then we have the right side as 2 to the power of 3x minus 9. Next, we are going to combine our left side because this is with multiplication. So we are using the product rule of your exponent, in which once we have the same base, all we have to do is to add up our exponents. So copying the common base here as 2, we have 2x minus 6 on the first exponent, adding that up to our second exponent, which is negative 8x plus 8. And then we have that equal to 2 to the power of 3x minus 9. Next, we are combining like terms on our left side exponent. So we have 2 to the power of 2x plus negative 8x. That will be negative 6x. Negative 6 plus 8, that will be positive 2. And this is equal to 2 to the power of 3x minus 9. So since their bases are the same using the property of your exponential equation, so we then equate their exponents. So getting the exponent on the left side, we have negative 6x plus 2. And then equating that on the right side exponent, we have 3x minus 9. Combining like terms, we move 3x here and 2 on the right side. So we have negative 6x minus 3x. That will be equal to negative 9 minus 2. Negative 6x minus 3x is negative 9x. That will be equal to negative 9 minus 2. That's negative 11. We're dividing this by negative 9, and so with this one. So we have our x is equal to 11 over 9. So that will be our x on the exponent. Okay? You can try to check that out by simply plugging in x, which is equal to 11 over 9 on your original equation. And once you have left side and right side equal, then that means we have the right solution. So let's go to our last example here. So we have here on the right side, there are two bases that are not the same. So again, we will be expressing our bases on the right side into similar bases. And noticing that our base on the left side is with base 5. So that would simply mean that 25 and 125 can be expressed in terms of base 5. So let's try to have that one here. So again, we have here 5 to the power of x plus 5. We just simply copy that one. That will be equal to 25. 25 will express this into 5 to the power of 2. Then we raise our entire 5 to the power 2 to the exponent, which is 2x. And then we have 125. 125 is simply, if we try to break that down into 5 as one factor, This is 5 times 25. And we have 25 as 5 times 5. So there are 3 5s on 125. So again, we have 125 as 5 cubed. And then we still have a power here or exponent, which is 2. Simplifying that one, so we have 5 to the power of x plus 5. This is equal to power rule again. This is 5. 2 times 2x, that will be 4x on the exponent. And then power to power rule again, so we have 5 to the power of 3 times 2, that will be 6. There you go. And then we try to simplify the right side into single base. Their bases are the same, so we just have to add their exponents. So 5 here will be with an exponent which is 4x, and then adding the other exponent. So we can now equate our exponents because we have single bases on right side and left side. So we have x plus 5 equal to 4x plus 6. Then we combine like terms, moving 4x here, 5 there. So this is now x minus 4x. That will be equal to 6 minus 5. We have negative 3x for this, and this is equal to 1. So solving for our x, we just have to divide this one with negative 3, and so with this one with negative 3. So our x is equal to negative 1/3. So there you go. Now, if you want to, you can still watch for another pattern in this exponential equation problem. You can try to look for my other video. I've got other 3 parts of it with different formatting on the problem. So kindly look for that one and see how to solve an exponential equation with that kind of problem or pattern on the problem. So again, this is your teacher Jenny saying in every problem you've got a solution for that one. So it's up to you really to look at the steps and notice that all in a particular problem you will have there the same steps. And of course, you will be also solving that one with similar steps and procedure. Although you can find a better steps or procedure to solve your problem because as your problem arises more often, then you would know how to solve that one in a more um, a more leveled up version of your solution. So again, this is your teacher Jenny saying good luck in every challenges in your life, and please like, share and subscribe my video and subscribe in my channel. Bye.